You know, every rock tells a story, and when you start piecing all those stories together, you get something incredible: the biography of our planet. It's this epic tale that stretches back 4.5 billion years, long before anyone was around to write it down. So, how in the world do we read a history that's literally written in stone? Well, the clues are all around us. You just have to know where to look. And it can all start with something ridiculously simple, like a piece of chalk. Way back in 1868, a scientist named Thomas Henry Huxley used a single piece of chalk to completely blow his audience's mind. He explained that these famous white cliffs aren't just rock, they're the compressed remains of countless microscopic sea creatures that lived and died millions of years ago in a warm, shallow ocean that covered Europe. I mean, a single piece of chalk becomes a window into a completely different world. It's wild. So what Huxley was getting at here is actually pretty profound, right? If you can understand the deep history of something so ordinary, you gain a whole new perspective on, well, everything. You start to see the world not as some static stage for us to walk on, but as this dynamic, ever-changing character in its own incredible story. Okay, but that brings up a huge question, doesn't it? With no books, no witnesses for pretty much its entire history, how do geologists actually read this 4.56 billion-year-old story? Well, they basically become detectives, piecing together clues from the Earth itself. And here are their main tools of the trade. Geologists can actually identify the ghosts of ancient mountain ranges that have long since eroded away. They trace the evolution of life through fossils. They can even read these tiny magnetic signatures trapped in rocks to figure out where the continents used to be on the globe. And the real game changer? Isotopic dating. It's kind of like finding an atomic clock inside minerals that lets them put a precise timestamp on all these ancient events. Every rock is like a page in the planet's diary. All right, let's turn to chapter 1. And let me tell you, it's a time so violent and just so alien it's almost impossible to imagine. This is the Hadean and Archean eons, the first 2 billion years of Earth's life. So the story kicks off with our planet forming from a swirling disk of dust and gas. But things didn't stay peaceful for long. Just 30 million years in, a Mars-sized object we call Theia slams into Earth, blasting a cloud of debris into orbit that eventually came together to form our moon. Then, for the next several 100 million years, during a period called the Late Heavy Bombardment, the planet was just relentlessly pummeled by meteorites. It's only after all that chaos finally died down that a stable crust and the first permanent oceans could finally form. This slide really shows you the stark contrast. On the left, you've got Hadean Earth, literally a seething ocean of magma. Any crust that tried to form was just immediately destroyed by another impact or recycled back into the mantle. But on the right, you see the Archean, still a super harsh world for sure with a toxic atmosphere, but with a revolutionary new feature: liquid water. This is the moment Earth starts to become the water world we know. And what's kind of surprising here is just how quickly our land masses came together. We tend to think of continents as these ancient, slow-moving things, but the data shows that about 80% of the continental crust we live on today was already formed by the end of the Archean, just 2 billion years into Earth's story. These first little protocontinents grew from colliding volcanic island arcs and hotspots in those brand new oceans. And as these continents were taking shape, something truly incredible happened in the shallow waters along their coastlines. Life appeared. Now, this isn't a T-Rex, it's much, much more humble. These lumpy mounds are called stromatolites, and they're built by mats of microbes. We're looking at modern ones here in Australia, but we found their fossilized ancestors in rocks that date back 3.5 billion years. This is life's first great success story. Okay, so for Act 2, the Proterozoic Eon, life doesn't just cling to existence, it becomes a geological force in its own right, an agent of change that is going to transform the entire planet. This is the Great Oxygenation Event, a total turning point for all life to come. Those early microbes, specifically something called cyanobacteria, figured out photosynthesis, and their waste product, oxygen. Now, for hundreds of millions of years, the rocks in the ocean acted like a giant sponge, just soaking up this new and, frankly, toxic gas. But eventually, that sponge got full, and oxygen began to flood the atmosphere, paving the way for all the air-breathing life we know today. And the evidence for this? Well, it's brilliantly recorded in this rock called a banded iron formation. Those vibrant red layers? That's essentially rust. They formed when the new oxygen in the water combined with dissolved iron, causing it to literally rain down onto the seafloor. The entire ocean rusted, And these stunning rocks are the proof. Meanwhile, up on the surface, the continents continued their slow-motion dance. Around 1 billion years ago, most of Earth's landmasses smashed together to form a massive supercontinent called Rodinia. You can think of it as a key predecessor to the more famous Pangaea. But just as life was getting more complex in the oceans, the planet was heading for a crisis. The world was relatively warm, life was diversifying, and then the climate took a radical, catastrophic turn. The clue that had geologists scratching their heads for years came from rocks just like these. They started finding evidence of glaciers, rocks dropped by melting ice sheets, in places that, according to the magnetic data, were sitting right at the equator back in the late Proterozoic. I mean, let that sink in for a moment. Glaciers at the equator. For ice to exist at the warmest part of the planet, the entire Earth must have been unbelievably cold. What in the world could possibly explain this? The leading theory is as dramatic as it sounds: snowball Earth. The idea is the planet may have frozen over completely, from the poles all the way to the equator. So what saved us? Volcanoes. They just kept pumping CO2 into the atmosphere, and since the oceans were covered in ice, that CO2 had nowhere to go. Eventually, it created this intense greenhouse effect that rapidly melted the snowball and reset the climate. And that great thought would have flushed a massive amount of nutrients into the oceans, setting the stage for life's next big leap. After that big thaw, we enter the final act of our story, the Phanerozoic Eon. This is the eon of visible life, when the world finally starts to look a little bit more familiar to us. The Phanerozoic is basically broken down into 3 major eras. First, you've got the Paleozoic, or ancient life, which is where complex life just explodes in the oceans and starts to colonize land. Then comes the Mesozoic, middle life, which is famous as the age of dinosaurs. And finally, the Cenozoic, recent life, which is the age of mammals, and that's the one we're still in today. Right at the very beginning of the Paleozoic, probably fueled by that post-snowball nutrient rush and all that new oxygen, life underwent a stunning diversification known as the Cambrian explosion. I mean, it's called an explosion for a reason. Suddenly, the fossil record is just filled with animals with hard parts: shells, skeletons, teeth. The oceans were teeming with all these bizarre and wonderful creatures like trilobites, as life experimented with basically every body plan you can imagine. Tectonically, this whole era was like a slow-motion demolition derby. Through a series of massive continental collisions, the pieces came together one last time to form the ultimate supercontinent, Pangaea. That final collision, which smashed Africa into North America, was so powerful it raised a mountain range as mighty as the modern Himalayas. Today, we know its eroded remnants as the Appalachians. The Mesozoic era kicks off with Pangaea beginning to break apart. As the continents rifted away from each other, new oceans like the Atlantic were born, and that single landmass became many isolated continents. This changing geography, combined with a mild global climate, created the perfect stage for the evolution and diversification of a new dynasty of creatures, the dinosaurs. And wow, what a dynasty it was. For an incredible 150 million years, dinosaurs dominated this planet. Gigantic sauropods literally shook the ground, while flying reptiles ruled the skies. It was during this time that the first true birds took flight. And all the while, our own ancestors, the first mammals, were just these small, shrew-like creatures, living in the shadows of these giants, just biding their time. From a magma ocean to a snowball, from microbial mats to towering dinosaurs, the Earth's biography is just a story of incredible, constant transformation. And in this immense 4.56 billion years saga, our own human chapter has barely even begun. It really makes you wonder, doesn't it? What will we write on the next page?